एकदा ऑनलाईन लेक्चरवर आपण भेटत आहोत. मध्ये थोडंसं ऑनलाईन लेक्चरच्या बाबतीत काही प्रॉब्लेम्स नंतर परत एकदा आपण या ऑनलाईन लेक्चर सिरीजमध्ये भेटणार आहोत. बोर्डचा सिलेबस आलेला आहे. तुम्ही कदाचित अभ्यास करायला सुरुवात केलेली असेल. काही पॅरेंट्सचे असे पण फोन आहेत, मुलं घरी अभ्यास करत नाही, काहीतरी त्यांना अभ्यास द्यावा लागेल. ठीक आहे, सगळ्यांसाठी एकच आहे, 11चे बुक्स आहेत ते बुक्स कवर करा. सगळा जो पार्ट आहे, बेस पार्ट आहे, तो 11ला आहे. तो पार्ट क्लिअर असल्याशिवाय 12थला मजा येणार नाही. आपण तेवढं त्याच्यासाठी तयार असणार नाही आहे. त्याच्यासाठी सर्वांनी 11चे बुकमधला जो पार्ट आहे तो चांगला कवर करून घ्या. 12चे बुक पण तुमच्या रेफरन्सला आहेतच आहे आणि आपण काही व्हिडिओमध्ये पार्ट कवर करणारच आहे. तर थोडंसं सिलेबस पाहिल्यानंतर तुमच्या लक्षात आलं असेल, आपण सिम्पल हार्मोनिक मोशनवर थोडंसं डिस्कशन केलेलंच आहे. थोडंसं म्हणण्यापेक्षा तो जो चॅप्टर दिलेला आहे आपल्याला सिलेबसमध्ये, त्याच्यामधला 90% पार्ट आपण कवर केलेला आहे. 10% काही ॲप्लिकेशन बेस आहेत, त्याचा पार्ट आपण पुढे कवर करणारच आहे. त्याच्यानंतर जो पार्ट आपण रोटेशनल मोशन म्हणून कवर केला होता, तो रोटेशनल डायनॅमिक्स म्हणून तो चॅप्टर आहे. तुमच्या स्क्रीनवर तुम्हाला दिसत असेल रोटेशनल डायनॅमिक्स हा म्हणून एक चॅप्टर आहे. फर्स्ट चॅप्टरमध्ये गिवन आहे. त्याच्यातला जो 50% पार्ट आहे रोटेशनल मोशनचा, तो आपण कवर केलेला आहे. त्याच्यातला काही पार्ट आहे सर्क्युलर मोशनचा, तो आपण कंटिन्यू करणार आहोत. सर्क्युलर मोशनचा काही कन्सेप्ट आहेत, ते 11ला बेसिक पार्ट होता, तो कवर केलेला आहे. त्याची डेफिनेशन काय आहे, युनिफॉर्म सर्क्युलर मोशन काय असणार आहे, रेडियल ॲक्सेलरेशन काय असणार आहे, तोच कन्सेप्ट कंटिन्यू करून ॲप्लिकेशन्स बेस सिलेबसमध्ये ॲड केलेला आहे आणि खूप चांगल्या सिलेबसमध्ये ॲड केलेला पार्ट आहे. याच्यावर प्रत्येक म्हणजे CET असेल, JEE असेल, नीट असेल, या सगळ्या एक्झामला तो पार्ट दिलेला असतोच आहे. त्याच्यावर क्वेश्चन्स विचारले जात आहेत आणि तोच पार्ट आपल्याला त्याच्यामध्ये ॲड केलेला दिसतो आहे. त्याच्यामुळे आपल्याला तो चांगला पार्ट कवर करून घ्यायचा आहे. आपण या ऑनलाईन लेक्चर्समध्ये तो पार्ट कवर करणारच आहे. ज्यावेळेस रेग्युलर क्लास सुरू होतीलच काही दिवसानंतरच लगेच सुरू होतील, तर त्यावेळेस आपण तो पार्ट परत एकदा थोडासा रिवाईज करूच आहे. पण तोपर्यंत आपल्याला तो पार्ट अंडरस्टँड होईल आणि शिवाय तुमच्याकडे PDF आहेत, त्या PDFमधून तो पार्ट तुम्ही परत एकदा काही कवर करणार आहात आहे. तर चलो, आपण तो पार्टकडे थोडंसं फोकस करायला घेऊया. तुम्हाला स्क्रीनवर दिसत असेल एक रोटेशनल डायनॅमिक्स म्हणून चॅप्टर आहे, किंवा तुम्ही सिलेबसमध्ये पण पाहिलं असेल, तो चॅप्टरकडे आपण थोडं पुढे जात आहोत. तर त्याच्यामध्ये सुरुवातीला फर्स्ट पार्ट जो येतो तो सर्क्युलर मोशन आणि रोटेशनल मोशन याच्यावर थोडंसं कंपॅरिझन दिलेलं आहे. आणि वी नो द डेफिनेशन ऑफ ए सर्क्युलर मोशन अँड रोटेशनल मोशन. व्हॉट इज अन सर्क्युलर मोशन? जर तुम्हाला काही एक्झाम्पल्स समोर दिसत असतील तर त्या एक्झाम्पल्सवरून थोडीशी आयडिया येत असेल तुम्हाला. If the particle moving along a circumference of a circle, if the particle moving along a circumference of a circle about a center, it's called as a circular motion. And a body means it is a combination of a number of particles. बॉडी मीन्स इज अ कॉम्बिनेशन ऑफ नंबर ऑफ पार्टिकल्स. सपोज जर तुम्ही माझा चेहरा पाहत आहे, माझी बॉडी पाहत आहे, त्याच्यामध्ये नंबर ऑफ पार्टिकल्स आहेत. त्या पार्टिकल्सपासून सेल्स आहेत, टिश्यू आहेत, त्यांच्यापासून ती बॉडी बनलेली आहे. जर तुम्ही स्टोन घेतला तर स्टोनला जर आपण त्याच्यावर अटॅक केला किंवा त्याला क्रश केलं तर छोटे छोटे पार्टिकल्स तयार होतील. मीन्स लाईक दॅट वन्स दॅट ऑब्जेक्ट मेड फ्रॉम द नंबर ऑफ स्मॉल पार्टिकल्स. Okay, then after that one we discuss about the details of a circular motion and rotational motions. Okay, and in that chapter we discuss that few points. Here we firstly cover that points. Which points are required in that ones, or here we discuss this on circular motion and rotational motion. Actually this part is studied in 11th standard, as well as we discuss about the rotational motion chapter, and in that chapter we discuss the difference in between them, circular motion and rotational motion. Okay, then after that one we discuss about the characteristics of circular motion. The two main characteristics of a circular motions are there. Here we discuss about that characteristics. After that one, kinematics of a circular motion. In that kinematics we discuss about the definition of angular quantities. If we consider the any motion, in that motion the three major physical quantities are there. One is displacement, second one is velocity, third one is an acceleration. And in that concept of a circular and rotational motion we discuss about the linear displacement as well as angular displacement, and linear velocity, angular velocity, linear acceleration and angular acceleration. And after that once we discuss its relations. Okay, then after that one, lastly we discuss about the uniform circular motions. Actually this uniform circular motion part is covered in 11 standards. The limitations for the circular motions are added in that ones, and from that one we discuss about this uniform circular motions. Okay, observe the screen, and in that screen here we write the definition. Actually you know the definition of a circular motion and rotational motion. Before reading that ones, you remember uh, about that concept of a circular and rotational motion. First one is in case of a circular motion only one particle is there, and in case of rotational motion we discuss about the body or object that made from the number of particles. Okay, now we cover the definition of this one. A particle moving along a circumference of circle. Okay, uh, actually is not necessary the particle complete the whole circle. In some cases the particle moving on a arc of these circles means some part of this circle. Okay, this concept also added in a circular motion. Therefore here we write this definition as a particle moving along a circumference of circle about a center is called a circular motion. And we know the some examples of circular motion because this part is already covered in 11 standards. One example is an electron revolves around the nucleus, or another one is an car moving along a circular path. Or also we discuss some here we observe some examples. In that all the examples we consider that particle and that particle moving around a one center. Observe these examples. These examples are of a circular motions. Okay, then after that one we discuss the rotational motion. What is the rotational motion? A body rotate about its own axis. Actually body is an combination of a number of particles. If the body rotate about its own axis, then all the particle performs a circular motion about its center. Okay, then the examples of this one: earth rotate about its own axis, or we can take examples of a fan, door rotate about its own axis, like that ones. These are the simple examples of these rotational motions. Okay, after that once we discuss about the characteristics of a circular motions. Okay, now we focus on a base of these circular motions. Characteristics, the first one is an accelerated motions. If we consider the circular motion, then this motion is an accelerated motions. Okay, we know this concept of a accelerated motions. Suppose if we consider this is an circumference of a circle, and if we consider the position of a particle in that case, then this is an one position. If we draw the direction of a velocity, then this direction is like this ones. We can draw the direction of velocity at this position. We can draw the direction of velocity in that ones. This one means the direction of a velocity continuously change, and we know that the definition of acceleration is a change in velocity with respect to time. And in case of a circular motion, the direction of a velocity continuously change, which means that there is a accelerations. In case of linear motion, if we consider this is an one body that get moving in a straight line like this ones, in case of linear motion the direction of the velocity is in same ones, then this is not an accelerated motion if the speed is in constant ones. But in case of circular motion, in every example of a circular motion, the direction of the velocity gets changed, and due to the change in direction this motion becomes accelerated motion. Okay, the next ones, it is on periodic motion. What is on periodic motion? Periodic means actually this is not a periodic in time. Periodic actually another periodic is an periodic in space, like that ones. If we consider about the circular motion, in that one the particle moving along a circumference of circle like this ones, and that particle continuously moving along this circumference of this circle, then the distance covered by the particle in every circumference is an same one. Okay, and if the distance is an same one, then we can say that this motion is an periodic motion. Therefore in that concept we say that uh, particle repeat its path again and again. Therefore, this motion is an periodic motion. These are the two major characteristics of these circular motions. Okay, remember that that characteristics used in an MCQ. First one is an circular motion is an accelerated motion, and it is an periodic motion. Then after that one, we know the some definitions. Actually, the definitions are covered in 11 standards. This one is an angular displacement. If we consider about the circular motion, then in that circular motion, this first initial position of the particle is at here. If we say that this is at center, then the position of the particle drawn from this center, this is called as a position vector, or also called as a radius vector. After some time, if the particle moving up to here, then its position can be drawn like this ones. Okay, then change in a position is a displacement, and that change in position shown by a radius vector. Therefore, here we say that angle described by the radius vector. Therefore, here we say that angle described by the radius vector, it's called as, and at the center of a circle, it's called as an angular displacement. Okay, means that concept is discussed in that part once. Okay, then after that one, angular velocity. This is a simple definition of a is like a linear velocity. In case of linear velocity, we know that change in displacement with respect to time is called as a velocity. Like that once, in case of angular velocity, change in a angular displacement with respect to time, or we can say that rate of change of limiting angular displacement. Why we use that word limiting? Okay, why we use that word limiting? Concentrate here. If we consider this is a circumference along which the particle get moving, and if we say that initial position is at here, this is a position vector or radius vector. After some time, this particle get moving from this position up to here, then its position vector can be drawn like this ones. If we take this angular displacement, then this angular displacement is on theta, and this angle is very large. Then this path is not a straight line, this is like a curve path. Then to write the formulae for that one is a difficult ones. Therefore, here we avoid this concept and use for the linear one. Then we consider the small displacement of the particle. If we take this small displacement, then this is like a straight line. We can combine these formulas and of a linear and angular displacement. For that purpose, we consider this angle is a very small one. Therefore, here we write limiting angular displacement, and due to that once we take a limit function for that ones. Observe this is a limit function in that definition. Actually, this notation is of a omega. We know that we use a notation omega for this angular velocity. Okay, then after that one, we discuss about the angular acceleration. This is a similar definition of this ones. Angular acceleration is an change in a velocity with respect to time. Observe this definition, there nothing more in that ones. Actually, angular acceleration is an change in angular velocity with respect to time. This is an also limiting value, and this is an angular accelerations. Okay, then after that once we discuss about the direction of this angular displacement, angular velocity, and angular accelerations, and its direction can be shown by using an right hand thumb rule. This part is already discussed in an 11th. By using a right hand thumb rule, we can show the direction of an angular displacement, angular velocity, as well as angular acceleration. What is this right hand thumb rule? We know that straight the thumb, other fingers are curled around these ones. If the curled finger shows the direction of motion of the particle, then the thumb shows the direction of a angular displacement as well as angular velocity. Okay, then after that once, if the angular velocity get increase, then alpha means angular acceleration is positive. then the direction of a angular acceleration and angular velocity is also same. But for that purpose, the angular velocity must be increased. Now here we take one examples. Suppose one particle moving along a circumference of a circle, and its velocity continuously increase like this ones. In that one, the direction of a angular velocity and angular acceleration alpha is unsame. But if the angular velocity decreases, then the direction of an angular acceleration is opposite to the omega, means angular velocity. Remember this part. Okay, then here we discuss the some basic concept of this uh, circular motion. In that once the physical quantities are required, we discuss about that physical quantities, we take some definition, and after that one we also show the direction of this angular displacement, angular velocity and angular acceleration in that ones. Okay friends, we continue this circular motion part in a next video. Bye.